Hello everyone, welcome to the new lecture series of the topic of rotational motion. In this playlist, I am going to cover some topics of rotational motion, that is what is rotational motion basically is, and what is torque, what is moment of inertia, and we'll find out moment of inertia of different bodies. We'll cover the angular momentum and the conservation of angular momentum, and we will see what can be done. So what is rotational motion? So far you guys already know that when we are interested in one particle motion rotating with respect to one particular point, that is called circular motion. That is called circular motion. So in rotational motion, there will be many particles there which will be rigidly attached to each other. There will be many particles there. Suppose this is rod. In this rod, we can find out many particles or many this kind of particles which are rotating with respect to one fixed axis. And the cumulative motion of all these particles rigidly attached will be discussed in this rotational motion chapter. And those cumulative motion is called rotational motion with respect to this particular axis. Now, before starting any topic of rotational motion, we'll see what is rigid body. So that concept is required to study the rotational motion. So rigid body is a body, suppose in this case this is rod, the deformation is not possible. If I apply some force like this, or if I can apply some force like this also, there will be no deformation possible for this body, then that will be called rigid body. Or we can tell in realistically that in rigid body, whatever amount of force you apply, the deformation will be very less compared to its dimension. Suppose its dimension is L is the length of the rigid body. So deformation due to application of all these forces will be very less than L or very less than its dimension. Then that will also be called a rigid body. Or we can also tell that the deformation of the body will ignore. Compared to its motion, will ignore the deformation of the body. Then that will be called rigid body. Now in rotational motion chapter, we will be considering all bodies as rigid bodies. And then we will consider the motion of the rigid body with respect to one axis. Now the first topic I am going to start of rotational motion is torque. What is torque and how torque is generated? Now say this is a rod and this is the pivot point of the rod. Now this rod is a rigid body. Now I am applying the force F in this direction. So this is the point of application of the force. This point, the top point is the point of application of the force. And right now the rod is in the vertical position. So we can draw X and Y axis like this. Now this F force is applied on the top of the rod, making angle theta with the direction vector. So see, it is rotating with respect to this point. That means we will consider it as origin or the pivot point. And here this is the point of application of the force. So for this point, the direction vector will be from this pivot point will count. So for this, let's say the rod length is L. The pivot point, what is the direction vector? R will write. In this configuration it is L into J cap will write. Now torque is considered as the capability of a force to rotate a body. So see, this body is fixed at this point. So there is no way if we apply this force, this will go with some acceleration in the direction of the force. Rather, what will happen? This force will try to make this body rotate with respect to this pivot point. Now, in this torque, basically, we are going to measure the capability of this force to rotate this body. So now what is the torque? How much torque is generated due to application of force in this direction, theta angle. So the method 1, how to calculate the amount of torque or the capability of the force to rotate the body. So method 1 is you have to draw one perpendicular to the direction of the application of the force. So see, this is the force applied, so this is the direction of the application of the force. I can extend it. Now I have to draw one perpendicular on this line. This is the perpendicular on this line. So torque is perpendicular distance into that value of the force, that is the torque. Now what is the perpendicular distance here? So see, this is theta means this is also theta, and if this is L, this perpendicular distance is L into sine theta. So we can write that L sine theta into F, that is the torque. Or so we can also write that R cross F, that is the amount of torque. Now see, torque is a vector quantity, so that is why we are denoting the torque with the cross product. See, R is also a vector, that is the distance vector of this point with respect to the pivot point. F is also a vector, so their cross product will also give rise to a vector quantity only. Now what is the angle between this direction vector and the force? So see, for this point the direction vector is this direction, this is the direction vector, and the angle between the direction vector and the force is theta. So torque is basically R into F sine theta. So in this case R is basically L, so that is why L F sine theta is coming. And as I told, this is a vector quantity, then what will be the direction of this? So this is the magnitude of the torque, Rf into F sin theta, or L into F sin theta is the magnitude of the torque. Then what is the direction of the torque? So see, this F is trying to rotate the body in this clockwise direction, because if you apply force in this direction, it will try to rotate the body in the clockwise direction. So see, so if x axis is like this, y axis is like this, so outward is the z axis, outward. Z axis is outward. If it is trying to rotate the body clockwise, then the direction of the torque is R cross F, that means inside the board. So we can write that it is negative z axis. So torque vector is LF sin theta into minus k. We can write that. Now we are grown up, so we will not use clockwise, anti-clockwise, all these things. We will just denote with the unit vector, minus k in this case. So there is another method to find out the torque. So one method is, as I told, perpendicular distance I have to draw on the direction of the force. That distance multiplied by the force will be the value of the torque. Now we'll go to method 2. Method 2, how to find out the torque. See, F force is having two components. One is this horizontal component, that is F, in this case F sin theta. Another is F cos theta. Two components are there. One is F sin theta, another is F cos theta. So the F sin theta component is acting perpendicularly to the direction vector, and F cos theta component is along the direction vector. So now we'll divide the problem into two parts. One is F cos theta is getting applied in this direction, plus this pivot point is there, another force is getting applied is F sin theta. So see, due to this force component, it is not able to rotate this body because this force is exactly matching with the direction vector, or it is axial component. So this force component will not be able to rotate this body in any direction. This is axial force component. This is axial component. But see, this force, this component of the force F is able to rotate the body in the clockwise direction, as we discussed in the method 1. Now the direction of application of the force is this one, horizontally. If I draw perpendicular, then the direction is this one. So the distance will be L only. L is the length of the rod. So we can directly find out the torque by multiplying the perpendicular distance into the force. So L into F sin theta we can write. And again this is rotating in clockwise direction, so the vector will be minus K cap. So this is the T. So this is the method 2. So torque we can write as R, the direction vector, cross F. That is the takeaway from this torque calculation part. Now let us discuss one problem of the torque. Now see, this is a L-shaped body and force of 2 Newton is applied at this point at an angle 30 degree with the horizontal. And the dimension of this is 2 meter and dimension of this part is 1 meter. And x and y axis is given like this. Now you have to find out what is the amount of the torque. Torque is how much? You have to find out. See, so first method is, what is the direction vector of the point of application of the force? So see, this is the point. What is the direction vector of the point of application of the force? Let's say R. R is the vector of the point of application of the force, distance vector. And what is R? R is 1 meter at the x-axis and 2 meter at the y-axis. So we can write that 1 I cap plus 2 j cap. So this point is 1, 2, this point. So 1 I cap plus 2 j cap is the R. And now force is given as 2 Newton, is applied at angle 30 degree with the horizontal. So F we can resolve in two components. One is horizontal component, F cos 30. Another component is vertical component or y directional component, that is F sin 30. So if we write F also in the vector form, just we have written the distance vector, we can write the F vector also. F vector is F cos 30 is the x-axis component or x directional component. So we can write that F cos 30 I cap plus F sin 30 j cap. So what is the value of F? We'll just put it is 2. 2 into root 3 by 2 I cap plus 2 into half j cap. I'm just putting the value of cos 30 and sin 30. So it is becoming root 3 I cap plus j cap F. Now as you know, torque is R cross F. Now I cap plus 2 j cap cross root 3 I plus j. We can do this cross product and we can find out what is the amount of the torque. Let's do this. Ij 1 2 root 3 1. Ij 1 2, I have written here 1 2 0 and F is root 3 1 0. So see, only K component is there. So we can write that K cap into 1 minus 2 root 3. 1 into 1 minus 2 root 3. 1 minus 2 root 3 is the amount of the torque. You can find out. That is the one method I have solved it to find out the torque. Now let's solve it with another method. So method number 2. So see, this F, there is having two components. One is F cos 30, that is the horizontal component, and another is F sin 30, that is the vertical component. So what is F cos 30 component is doing? It is trying to rotate this body in the clockwise direction. Clockwise means in this case it is minus z axis, that is inside the board. So torque due to the F cos 30 component is perpendicular distance of the line of action of the F cos 30 force into F cos 30. What is the perpendicular distance of the F cos 30 component line of action? 2 perpendicular distance into 2 cos 30 but the direction is, it is trying to rotate in clockwise direction, so it is minus k cap. So 2 into 2 cos 30, that is 2 into 2 into root 3 by 2, that is 2 root 3 minus of k cap. Now there is another component of force F sin 30, so that is not basically the actual component, because F sin 30 is not getting applied exactly on the pivot point. So the line of action of the force is not matching with the pivot point. So this is the F sin 30. Now what is the perpendicular distance of this component of force from the pivot point? That is, if I draw perpendicular on this line of action of this force, this is 1 meter only, 1 meter. So torque due to F sin 30 component, that is the perpendicular distance on that force, that is 1 in this case, into the force component F sin 30, but that is trying to rotate it in anti-clockwise direction, and anti-clockwise means x cross y, z axis outward, so we can write it as plus k cap. That is 1 into 2 into half k cap, that is only 1 k cap torque. So total torque will be the addition of these two torques. One is 1 k cap and another is minus 2 root 3 k cap. So basically it is 1 minus 2 root 3 k cap torque, and that is Newton meter. The unit is Newton meter. Okay, I hope you understood this problem.